iOS comes with a built-in timer class that lets us run code on a regular basis. This uses a system of publishers that comes from an Apple framework called Combine. We've actually been using parts of Combine for many apps in this series, although it's unlikely you noticed it. For example, both the @published property wrapper and observable object protocols both come from Combine. But we didn't need to know that because when you import SwiftUI, we also implicitly import parts of Combine. Apple's core system library is called Foundation, and it gives us things like data, date, NS sort descriptor, user defaults, and much more. It also gives us a timer class, which is designed to run a function after a certain number of seconds, but it can also run code repeatedly. Combine adds an extension to this so timers can become publishers, which are things that announce when their value changes. This is where the @published property wrapper gets its name from, and timer publishers work the same way. When your time interval is reached, Combine will send an announcement out containing the current date and time. The code to create a timer publisher looks like this. Let timer equals timer.publish every one on.main in.common.autoconnect. That does several things all at once. First, it asks the timer to fire every 1 second. Second, it says the timer should run on the main thread. Third, it says the timer should run on the common run loop, which is the one you'll want to use most of the time. Run loops let iOS handle running code while the user is actively doing something, such as scrolling in a list. Fourth, it connects the timer immediately, which means it will start counting time. And fifth, it assigns the whole thing to the timer constant, so it stays alive. If you remember, back in Project 7 I said @publish is more or less half of @state. It sends change announcements that something else can monitor. In the case of regular publishers like this one, we have to catch the announcements by hand using a new modifier called onReceive. This accepts a publisher as its first parameter and a function to run as its second, and it will make sure that function is called whenever the publisher sends its change notification. For our timer example, we could receive its notifications like this: .onReceive, timer, time in, and then print the time is now time. That'll print the time every second until the time is finally stopped. Speaking of stopping the timer, it takes a little digging to stop the one we created. You see, the timer property we made is an auto-connected publisher, so we need to go to its upstream publisher to find the timer itself. From there, we can connect to the timer publisher and ask it to cancel itself. Honestly, if it weren't for code completion, this would be rather hard to find. For example, we could update our existing example so it fires a timer only 5 times, like this. @state, private var, counter equals 0. If self.counter is equal to 5, self.timer.upstream.connect.cancel. Else, print the time is now time. And then self.counter plus equals 1. Before we're done, there's one more important timer concept I want to show you. If you're okay with your timer having a little float, you can specify some tolerance. This allows iOS to perform important energy optimization because it can fire the timer at any point between its scheduled fire time and its scheduled fire time plus a tolerance you specify. In practice, this means the system can perform timer coalescing. It can push back your timer just a little so it fires at the same time as one or more other timers, which means it can keep the CPU idling more and save battery power. As an example, this adds half a second of tolerance to our timer. Tolerance 0.5. If you need to keep time strictly, then leaving off the tolerance parameter will make your timer as accurate as possible. But please note that even without any tolerance, the timer class is still best effort. The system makes no guarantee it will execute precisely.